This is Dr. Fred DePiro. This video is on mesh current analysis. It's part 3 of 3, and here we'll talk about using a super mesh. Following this, with some practice, you'll be able to handle voltage and current sources, and to do so with a little bit quicker and easier approach using the super mesh. You'll need to be familiar with doing a mesh analysis that involves both voltage and current sources in order to use this technique. So here's the method that we talked about before, and as you see, it includes this step for handling a current source that involves defining a new voltage, a new unknown associated with the voltage across the current source, as well as a new equation. Here's an example of that as a review. You see the current source on a shared branch. Okay? Because it's on a shared branch and we're doing KVL around each mesh, that means we have to introduce a new unknown that's called Vx in this case. Because we introduce a new unknown, that also means we have to introduce another equation. Okay? One way to do that is to go to a node that involves currents associated with our unknowns, the mesh currents, I1 and I2 in this case, as well as the current associated with the current source. This top middle node is an example of that. And we can form what's sometimes called an auxiliary equation by using KCL at that node. So using this type of approach, we end up with a set of, we call them standard equations. 3 equations in this case. Let's compare that to the approach using a super mesh. Okay, so using the super mesh, we have an alternate path that we can follow. It's a loop, an alternate place to do KVL. That is shown here in red. Let's see what happens when we do KVL around this loop. So going around here, we're going to have 12 as this upper left resistor, and we have to multiply that by the mesh current in the left mesh. So that's 12I1. Continuing on this red path, the sum of these resistors is 24. So over on the contribution on the right-hand mesh is a total of 24 ohms, and there mesh current I2 is involved. So you see we have this one equation with 2 different mesh currents in it. So we're going to need another equation in order to solve. So we pull in the auxiliary equation that we had discussed previously associated with doing KCL at this top middle node. Thus, via the super mesh approach, we have 2 equations and 2 unknowns. Via the standard formulation, we have 3 equations, 3 unknowns. Now, how are these related? Okay, if we take the first 2 equations from the standard formulation and add them together, we get the super mesh equation. Okay? So there is a consistency between these 2 formulations, and they will both reveal the mesh currents. We can see in comparison that super mesh has fewer equations, and however, we do lose information on it. We don't have information on that Vx voltage across the current source. Using the standard approach, we have more equations, but we also have a more complete analysis. So it's your choice, whichever method you want to use, depending on the specific needs that you have in a given case. Okay, well, with a little practice, now you have an alternative way to do mesh analysis involving current sources.